Alright, welcome back to Meteorology 101. Just want to do a quick video. We got some supercells in Texas. Pretty good storms going through. The tornado warning was just issued at 7:55 Central Time. I want to break these storms down a little bit. See what we got here. So we know we got low pressure. I'm going to pull up a surface chart real quick, see what our systems are here. Let me go to get you over on the same page I'm on. I have high pressure in the central U.S., low pressure down over Texas. We got that onshore flow, warm air advection. There should be a baroclinic system. A lot of warm air advection being pushed up from the Gulf of Mexico. Pretty strong winds. Let me get to some surface plots here. Okay, we got winds about 10 to 15 knots being pushed on shore. That low pressure system moved to the northeast. That's still baroclinic, still pretty significant system there. So I'd like to pull some upper levels on that, see what's going on, but probably won't do that right now. I just want to focus on Texas. We got some severe weather moving through Texas. So we're going to pull up our radar. This is just our radar loop. You see the rotation being indicated by radar, and they're finally throwing another warning up. I was looking at this about 5 minutes earlier than what they did, throwing this warning up, and you got this little hook here, but our hook started forming the way it should on the southwest quadrant of that thunderstorm, and that's a pretty significant thunderstorm right there. So definite rotation in that storm, so they should have had that warning out a little bit quicker than they did. So this is just our a base reflectivity. Let me see what we got for composite reflectivity. There we go. Now we're looking at some pretty significant 72 dBZs in the center of that storm. Let me get rid of the let me download this loop real quick, and then we can just pause it, get to the last shot. Okay, so you can see we got some pretty significant, we do have rotation and we do have that significant reflectivities. So get it over to another radar system here. We get on a base reflectivity, and then we can do a cross section of the storm. See what's going on there. Alright, let's see where we are. Trying to get you on the same page here. Why you're not seeing it? Just a second. Get rid of that one. There we go. Okay. So now we're on a base reflectivity, and this is just south of Dallas, Fort Worth. We have that cell going through. See the tornado warning. So let's do a cross section on the storm. We're going to go right across here, and there's little hooks. Let's see what we got. Right now we have about 67 dBZs, up about 24,000 feet. Actually, you can't see that one either. Just a second here. Alright, there we go. You can see the cross section now. So right there we got like I said, 67 dBZs, up just about 24,000 feet. So that's a pretty significant uplift on this thing. High reflectivities in the upper levels, so definitely severe. So let's do a 3D shot on this thing. See what we got for any kind of reflectivities in the upper levels. You see the overshooting tops about 40,000 feet. This is the lower dBZs on the outer edge of this thing, so we can knock that out of there and bring the higher reflectivities up. See where we're at. Once we get into this green, we get into the dBZs about 35 to 40 dBz. I mean, that's pretty significant being up there at 30,000 feet. So what we're looking for is about once you hit about 50 dBz, about 10,000 feet, that's where you start getting pretty severe. But this thing's already severe. I mean, we're cranking pretty good. You can see, looks like the updraft there, and definitely some rotation in that storm. So we can crank this all the way up into the 50 dBz's up to 60. Look at our areas. Now we got this purple. We'll get up into over 60 dBz's, and definitely some significant uplift on that. 30,000 feet, we're cranking high reflectivities of way in the upper levels. So we'll go back one here, and let's do pull up some rotation on this thing. See what we got for rotation. Significant rotation throughout that storm. So try to get a good picture of this. Well, you can see the rotation is starting to go vertical all the way up into the upper levels. So the southwest quadrant of that thunderstorm, this probably is a tornado possibly on the ground right there. So let's get the higher dBz's. We can bring the higher reflectivities, get rid of that lower reflectivity stuff. We can see our significant rotation down closer to the surface. Some in the upper levels, but we pull that. It's kind of chopped up a little bit, not 100% form, but you got, once you start getting that updraft, then that starts going a little horizontal, and you start building a downdraft, and then those two become wrapped around each other. You start getting the rotation, starts becoming vertical the way this is, and then bringing that tornado to the ground. So if there isn't a tornado on the ground right now, there's definitely a funnel cloud out there. We do have that significant rotation in that storm. So right here we're reporting 2.37 inches of hail with that reflectivity in those upper levels. That is all the hail given that higher reflectivity. So all right, we got get rid of that. We got another storm to the northeast. This is a severe thunderstorm. We're reporting here 3/4 inch hail. That's still, I think National Weather Service criteria is about 1 inch is considered severe, but this is still a severe thunderstorm warning. We're in a severe thunderstorm warning here and a tornado warning right now over Texas. So another one to the west of that. We're getting into the upper, about 60 dBz's on those two. So let's go ahead and break this one down. Let's just do a cross section on that so you can get getting to the 60 and dBz's up in the 60s, right around about 15,000 feet. So 50s all the way up into 27, almost up to 30,000 feet. So that's a pretty significant cell too. I mean, probably not significant rotation. We can we can do a 3D shot on that just to see what we got. Probably not a lot of rotation there, but still possible. It is severe, so I mean, we got overshooting tops up to about 40,000 feet there. So I mean, that's pretty significant. Break that down to the lower levels now. There's your higher reflectivities, 10 to 20,000 feet. And then we'll go back to the rotation. It's a little more scattered. So this is more like the horizontal I was talking about, getting a little more horizontal rotation. I mean, there's still rotation in this storm. That significant rotation. It just hasn't dropped that funnel cloud down yet to become a tornado. So there's still significant rotation. If it continues to build, then you possibly will see a tornado warning out of this one. But there's definitely rotation in the sky there. So all right, let's just hit those charts real quick. I just want to go just maybe to the 850. Let's just see what we got for the that low pressure system. Let's see how high that thing goes up. I want to see that one to the north that moved up. Still pretty well developed baroclinic low. Let me get you on the right page here. There we go. Okay, so we're trying to close off in that about 5,000 feet. It's not quite closed yet. Still should be pretty baroclinic. You got these highs and lows kind of, this chart's kind of pushing each a little close together. you got significant winds, but you're going pretty barotropical along the southeast United States. Baroclinic up in that area, so any significant weather is going to be, over Wisconsin, maybe a little bit more to the east where that surface low was over Michigan. So if we throw let me bump up my volume a little bit here for the station plots. These are the weather balloons that were let loose. Significant moisture all through the eastern United States, all the way down. This is probably an earlier run, say maybe 12Z from this morning. That's why we're not seeing the upper level moisture in Texas. I guarantee that moisture is there. We're seeing it at 40,000 feet. So it's not dry at 5,000 feet. I mean, you can get bases, above 5,000 feet for a thunderstorm, but I guarantee there's definitely should have been some moisture there. But ridging, the major shortwave, basically that's what I just call it, major shortwave trough. You got the baroclinic trough supporting that surface low. And if we go up one more level to the 700, let's go up there and throw our heights on. Now, like I said, we still see that trough, still see some troughing, and still baroclinic, so that's definitely a major shortwave. Still have upper level support for that. And then one more chart just to look at, just to go see what kind of jet support we have. That would be just see where our jet stream is and what kind of steer flow pattern we have for that low pressure system over Texas, Mexico. Probably going to take, typically once you have a low pressure system move through, that other low pressure is going to take the path of least resistance, so it's going to track right along with that low pressure system. There's several progging rules we can cover. I think it's too early to get into that stuff right now. I do want to start some basic weather classes. If I start talking about progging rules and even like major shortwave troughs, baroclinic, barotropic, upper level divergence, just kind of gets over people's heads. So, this not all of my listeners, but some of them. So I want to start with a basic class, so we can. I'm actually working on it now, but so we can get people on the same page, and then start understanding some of the terminology and what to look for on these charts, and that will get just give you that more of an understanding of what's going on in the atmosphere. So there's a low pressure system stacking back, probably that's an upper level low. We had that little bit of that low pressure system over Mexico that's probably all kind of developed together and then moved to the northeast. So what I'd say is it's going to track pretty much with that other storm, and then we'll probably should see that up into the Midwest states probably Thursday, Friday, something like that. But to keep an eye on that, it usually takes a couple days to get up that way. So I want to pull the jet stream. I'm pulling all the wrong stuff here. Let me go to the winds. And let's do some shading on that. Let's see our jet. So we still have that finger hanging down. That was all hanging down before, so it's almost like that deep troughing, long wave trough, then that long wave ridge, and that's going to be our steering pattern. So we get the long wave trough, your steering pattern is going to be pushing up to straight up to the northeast. So that should steer that low. Right, pretty much taking that same track. Let's get the pressure on here now. Isotherms. So when you get this sharp cut like this, we can throw some streamlines on there. You start getting that sharp cut, that's where you start getting possibility for a cutoff low. So this is just these are just kind of being the streamlines just being the steering flow. You can see the ridging and the troughing. So we got that troughing back here, this being from where that low pressure system is from the southwest. That's pretty much going to be your steer direction. Deep troughing up in Canada. So jet max over the northwest, jet max off the east coast. Pretty significant winds over the southeast United States also. If we can shoot up to the 200 millibar, we get one more going here. I'm not going to stay too long here. I just wanted to touch base on this thunderstorm stuff. That's the main reason I got on here. Let's get our winds. Now you can get pretty much of a different picture of that jet streaming way up in the upper levels. And there's a low pressure system over the four corners. That's upper level low. And we're still, got a baroclinic low all the way up to 200 millibars. I mean, that's you're pushing almost 40,000 feet there. To be baroclinic at them levels, that's pretty significant in the upper levels for that major shortwave. This is more of a kind of a long wave, but still baroclinic. I mean, that's real significant up in the upper levels. So that low pressure system, that thing could be creating some pretty significant lift over Michigan. Alright, so I'm going to get back to this radar real quick. Let's see what else we got going on here. Let's pull up the warnings window, and it's all down in Texas. Everything, all 3 warnings, tornado, and 2 severe warnings in Texas. That's pretty much what we have there. So let's go. Looks like maybe weakening a little bit. Let's play that loop. That's a pretty quick loop. Only getting a few shots on that thing. 1-inch hail. Do a quick cross section. Like I say, you're pretty bright in the upper levels, so the cross sections turned out pretty good. Let's go. We can move that around all along that cell. About 20,000 feet with the 60 to 70 dBZs. And we could twist this thing. So that's a pretty significant cell right there. One more on the 3D, and then we're going to let you go. Spread that out a little bit, but you can see those overshooting tops on this thing. And let's drop that lower reflectivities off of here. Start getting into them higher reflectivities up to 20, 30, 40,000 feet. I mean, you're cranking pretty good on that thing. So definitely severe thunderstorm. They do with the rotation. It's pretty much still got a little bit of rotation going on there. So those tornadoes are short-lived. So you can see how fast that can go away. We had all that rotation. Now we're pretty much dying down pretty good on the rotation. So that's going to be pretty much it for the video. If you like learn anything, just give me a like, maybe a comment. Let's help me out with the YouTube algorithms, and help me build this channel. So as the severe weather season comes, we'll start getting a little more into these things, and we'll get a little bit deeper into the weather charts, and we'll get some basic physics classes, and then we'll get into some atmospheric dynamics and start pushing this thing pretty good, and get everybody learning about the weather. Thank you for watching.